Okay, Summer, if you are watching this video, I just want to let you know that we have two special guests today in our classroom, Grady Rubel, Carly Anderson. I want you to know that Carly is claiming that you don't have the discipline that during your vacation that you would watch a video like this. I think in the biz we call that smack talk. And so Carly would like to challenge you to a dance-off when you come back. So fourth hour, you guys come back. I want to see you guys cut a rug. Right, Carly? Summer? She's in Paris. Summer in Paris. Okay. I don't know. Where is she, Taylor? Florida. The orange juice state. Okay. Let's do this. Solving difficult trigonometric equations. We're going to, this went very well second hour. We just like to make these slightly more difficult than the previous ones. And as you look at the first problem, we have 3 cosine squared of x plus 2 sine of x is equal to 1. What makes this more difficult than the previous problems we've done? We have different trigonometric functions. We have sine and we have cosine. So in this situation, I'm going to do a little trick here. I'm going to take this cosine squared, and I'm going to substitute 1 minus sine squared. That way, I will have both sine and cosine. I'm sorry, that way I'll just have sine in the very end. So I will have to do 3 times all that. So I'll have 3 minus 3 sine squared of x plus 2 sine of x is equal to 1. I'm now going to gather everything onto the right-hand side. I have a minus 3 sine squared. I want everything on the right-hand side. So I will have a positive 3 sine squared. I will have a minus 2 sine of x. And if I subtract the 3 over, I would have a minus 2. And that's all equal to 0. Any confusion so far? You could, but then I would have a negative 3, and I don't want a negative. It's harder for me to see how it factors. So now I have a positive 3. I have a negative 2 and a negative 2. Does this factor? Nope. Does not factor. So if it doesn't factor, what do I do? AC method is a method of factoring. Come on. Grady Rubel. If a quadratic does not factor, we must use the quadratic formula. Thank you, Samantha Stanley. Quadratic formula. Unfortunately for you, we haven't plugged into our calculators. So we take out our calculators. I put Grady on the spot there. He's like, quadratic formula. That was back when math was easy. Now I have to figure out the integral of secant squared. I hit program. Enter on quadratic formula. Enter. You hit the button that says PRGM. And so A is equal to 3. B is equal to negative 2. And C is equal to negative 2. Not exactly. We have 1.26 and 0.55. Well, normally when you solve these pieces, you get x equals, right? Well, instead of x, I have a sine of x. So now we have sine of x. 1.22? All right. Sine of x is 1.22 and sine of x is negative 0.55. You should see something right now. It should click in your brain. You should say yes. No. Somebody. Alex. It's more than one, so you can't do this. This is undefined because if you try sine inverse 1.22, you're going to get a domain error. Sine can't take on values greater than 1 or less than -1. So now I move to the other one. Could sine be equal to negative 0.55? Well, sure it could. Where is sine negative? 3 and 4, that's where it's negative. And remember, I told you guys yesterday that I'm going to adjust the way I teach this. Decide where it's negative, but then don't use that negative anymore. So we'll go second sine inverse. Instead of negative 0.55, we'll just go 0.55. And that tells me my reference angle, 33.37. So now I have my two solutions. 213.37 degrees and 326.63 degrees. What do you think? Good? So remember, we started by substituting 1 minus sine squared. We distributed it through. We realized it didn't factor. We used the quadratic formula. After we used the quadratic formula, we saw that there were no solutions to this one, but there were two solutions for that one. Okay, we move on. Example 2. 2 tangent of theta sine of theta minus tangent of theta equals 0. Michael hates drawing theta. You've obviously never tried to write the Chinese alphabet. That's a little bit more difficult. Right? Because they have a different symbol for every single word. Yeah. Never tried? We'll try tomorrow. Theta is like an egg with a crack in the middle. Hey, Jalen, what did 0 say to 8? Where'd you get the belt? Where'd you get the belt? You don't get it. Okay, all right. All right, what do you guys want to do here? We got tangent and sine of theta. What should we substitute in? Yes, very good. So just because you see two different trigonometric functions doesn't necessarily mean that you need to substitute something in. In this case, we're just going to write as tangent theta times 2 sine of theta minus 1 equals 0. So sometimes you can factor it out and make it work from there. So now I have two equations. Tangent of theta is equal to 0, and 2 sine of theta minus 1 equals 0. That means sine of theta is 1/2. Where's tangent equals 0? Zero and 360, but also 180. How do you know that? Look on your sheet. When you come up with values like 0 or 1 or -1, that's where you should really go to your sheet and look that stuff up. It'll probably help you. Carly and Grady remember always where tangent is equal to 0. They have trig in their brain. I'm lying. They forget it all the time. It's okay. It's an epidemic. We forget trig. Sine of theta is equal to 1/2. Where is sine positive? The first quadrant and the second quadrant. You're right, 30 degrees is my reference angle. It means I have two solutions there, 30 degrees and 150 degrees. I have a total of 5 solutions between 0 and 360 for this problem. There they are. On your test, I will not tell you how many solutions there are for each problem. Oh. I'm very, very sorry. Okay, example 3. 2, cotangent squared, 2x equals 3. We got 2 more examples, and you guys can get started. Short assignment, 6 problems. Two cotangent squared of 2x is equal to 3. What do you want to do first? What makes this problem unique from the others? I have a 2x. So that's like a double angle formula. So you might say, well, I should insert a double angle into there. Well, we don't really need to do that. What we can start out with is just dividing this 2 off. And I get cotangent squared of 2x is equal to 3 halves. I don't know how to work with cotangent squared. You can't divide. No. You can't divide that. There's a ton of stuff happening to that. Look at what's happening to that. That's like cotangent of 2x quantity squared. So, I mean, what? So you see that, Jalen? I mean, you got to do a lot of stuff in order to get rid of that 2. In order to get rid of that 2, you would have to, well, you'd have to square root it, and then you would have to inverse cotangent it in order to get at that 2. But we can't just cross that off. Grady question. Yes. All right. So I want to rewrite this in terms of tangent. So namely, tangent squared of 2x is equal to 2 over 3. Tangent squared of 2x is equal to 2 over 3. That's familiar, right? We've done that. What do we do to both sides? What? Well, that's my angle, just like theta. You don't flip theta upside down, do you? Whitney, you don't do this. You don't do sine of theta is equal to 1 over cosecant of 1 over theta. You don't do that, right? So we don't do that here. Okay, so I flipped that upside down. So now I need to solve for that. So what are you going to do to both sides? Square root it. That a boy, Levi. Even though you're not out for track, I'll still talk to you. Tangent of 2x is equal to plus or minus the square root of 2 over 3. Now, I got to get at this x. You know, you can see I'm going to have to divide by 2 at some point, right? But in order to get this 2x, what do I have to, how do I get rid of a tan? I inverse tan, right? So if we inverse tan both sides, we're going to come up with some interesting pieces. I set up my 4 quadrants. Positive in the first and the third, negative in the second and the fourth. And now I go to my calculator. Second, tangent inverse of the square root of 2 divided by 3. 39.23. What? What? Not yet. Now, Sam, when I inverse tan both sides, the tangent goes away, right? So what am I left with? 2x equals these 4 angles. The first one is 39.23 degrees. What's the second one? You guys help me out here. Do some math for me. 140.77. What's the third one? 219.23. And then all right, there's my 4 angles. That's equal to 2x. Now divide everything by 2. What's the first one? 19.6 about. Second is about what? 70.38. Oh, 9.6. On 60.38. Any questions on that? So look where we started. We divided by 2, square root both sides. That was it. Last one. Example 4. Now I have cosine and sine, so I've got 2 different trig functions. I can't factor anything out. So you start to look for something to substitute in. It's a heck of a lot easier to substitute something in if there's a squared, right? Maybe we better square both sides. What do you give if you square the left? Boil it out. Cosine squared of x plus 2 cosine of x plus 1 is equal to sine squared of x. What do we put in there? 1 minus cosine squared of x. That's what we put in there. So we come up with cosine squared of x plus 2 cosine of x plus 1 is 1 minus cosine squared of x. Now everything's written in terms of cosine. What do you want to do next? Gather everything over to one side. Okay, let's gather over to the left. So that'll be a 2 cosine squared. So we did that one and that one. Looks like I have a plus 2 cosine. Oh, forgot the x. Got that one. The ones cancel. Pull out a 2 cosine, good. Now what? Good. Where's cosine equals 0? Yep. Where's cosine equals -1? Nope. Just 180. What? It's negative. Now, you guys, we were pretty liberal with our algebra. Watch what we did. Let's say I have x equals to 1. And I square both sides. I get x squared is equal to 1. And then you solve. How many solutions you get? So we took an equation that had 1 solution and we created 2. When you square both sides, like we did, you run the risk of adding solutions. Remember when we divided sine off for both sides a couple days ago and we lost solutions? Well, here we squared both sides. We might have added a solution. So you got to check your answers. I'll show you the short way to check. Our original equation was this. Cosine of x plus 1 equals sine of x. If I simply get everything on one side, cosine of x plus 1 minus sine of x is equal to 0, I'm going to go to my calculator and I'm going to check to see if those answers work. We came up with 90, 180, and 270. And let's check to see if they work. On my calculator, I'm working in degrees. That's what I'm typing in. When I go to y equals, I type in cosine of x plus 1 minus sine of x. And I go second table. And now I can start typing in values. I type in 90. Yep, I get 0, so 90 worked. I type in 180. Yep, 180 works. I type in 270. I get 2. So 270 does not work. I added a solution. So that's our final answer. Six problems. Somebody added a couple at the end there. That wasn't very nice of them, was it? Was that Clayton? Clayton's not even in this class. What a 24? That's because Clayton's naughty. Let's reprimand Clayton tomorrow during advisory. Let's tell him that he needs to start acting like a senior, yes. Did he switch it over there too? What a naughty kid. All right. Wait a minute. No. Let me look. I think it is 44. Yeah, it is 44. It says 24 over there. Yep, it's 44. It is 44. It is 44. Yep. People messing with my board. Bye, Summer. We'll miss ya.